Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. Yeah, like always, we tell you, we have to remind you to subscribe. It is to your advantage. And it's me, Richard, once again. Now, we are looking at this question. It comes from Electrostatics. And it says, two spheres X and Y are placed as shown below. Okay, we have X, which is plus 5 microcoulomb, and Y, which is minus 3 microcoulomb. They said draw electric field pattern between X and Y. Okay, how do we go about this? This is what you have to know, that we are dealing with what? Unlike charges. So if we have a positive charge here, which is our X, and a negative charge here, which is our Y, and we are told to draw the pattern, this is what you have to remember, that these ones are unlike, so they like each other. They're unlike in terms of signs, so they like each other. So what do we have? We have fluxes which are coming from this side, enjoying that side. Is that okay? Even here, like that. Then you have to remember, these ones are supposed to come to be straight. So when they are coming like this one and they say good neighbor, they turn. When they are coming like this one, they say good neighbor, they turn. When they are coming like this one, they say good neighbor, they turn, like that. That's what each of this line means. Then there are these lines which does not know that there's a neighbor that side. They go straight. And even here, they come straight. Okay, that's how the pattern looks like. What comes after this is the direction. How do we get the direction? You put a positive charge. And the direction of the positive charge indicates the direction of the electric field. So when you put a positive charge here, where will it go? To the negative. So we are having these fluxes moving like that. Okay. How about these ones? When you put a positive charge, they'll be moving out. And here, they'll be moving in. And this is the pattern. Thank you. So we go to the next question. Okay. Then comes this question. It says, the spheres are now brought together and then separated. Okay. Then the question says, calculate the charge on each sphere after separation. So how do you go about this one? Okay. In this case, we use what we call the principle or the law of conservation of the charge. What does it say? That the total charge in a closed system is conserved or remains constant. So there is no loss of charge here. And we can put it simply as Q1 plus Q2 over 2 is equal to Q on each. Okay. So what is Q1? It is going to be the charge on X, which is going to be 5. Okay, when you put it in SI units, times 10 power minus 6 coulombs plus minus 3 times 10 power minus 6 over 2. What you get there will be the charge on each sphere. Here you have to take a note that you have to substitute in the sign of the charges. Okay? So that is that. So this happens to be the charge on each sphere after the two spheres have touched and then separated. Okay, then we go to the next question. So the question says, draw electric field pattern due to X and Y after separation. So this is what we have to take note of. Remember, after touching and separation, each one is now having a positive charge of 1 microcoulomb. So what are we going to draw? We are going to draw the field pattern between two positive charges. So if you have this one as our X, like charges, and like charges, they don't like each other according to the law of electrostatics. Actually, they repel each other. So remember, each line you put here, because this is not about designing, each line you put here has a meaning. What do we have here? We have lines which are supposed to radiate outwards, but as it moves, it finds a neighbor it doesn't want, so it curves. The same applies to this one. It wanted to go that side, it meets a neighbor it doesn't want, it curves like that. The same applies to this one. It wanted to come this side, it sees a very unwanted neighbor. The same applies to that one. Now you have to know that this repulsion we see here, this curving, goes on decreasing as we move outwards. So this is what we are having now. Then what? Then there is this which does not know that there's a neighbor that side it doesn't like, so for it just goes straight. The same applies here. It just goes straight. What is next is going to be indication of the direction of the electric field. And how do we get it? By placing a positive charge here. Where it goes will be the direction. So where will it go? Is it in or out? It is out. The same applies here. Okay, so what we have there is the electric field pattern between two positive charges. Okay, then comes this question 1.2.3. It says, which sphere lose electrons? You have to say X or Y and explain. Okay, when you look at, let's go back to our spheres. We have our spheres. This is positive and this is negative. So you need to know what positive and negative imply. Okay, what does positive imply? Positive is obtained by removal of electrons. As electrons are pumped out, a positive charge is created. So which means that a positive charge implies the fission of electrons. Okay. Then what does negative mean? Negative means excess of electrons. How do you create negative? By adding electrons to the neutral sphere. So now you have to know that electrons, they follow Brownian motion. They move from region of high concentration to the region of low concentration. Okay. So which of the sphere has excess electrons? It is sphere Y. It's negatively charged. And it's the one which is going to lose electrons. So the answer is going to be sphere Y. Okay, why sphere Y? The explanation is that sphere Y has excess electrons, and the electrons move from where they are highly concentrated to the region where they have low concentration. So the answer is Y has excess electrons. Thank you. So that's that. And we are going to cut this video here. We thank you for your time. Don't forget that the channel is PSSB, Physical Sciences Silver Bullet. And it's me, Richard. See you next time. Don't forget to subscribe. And don't forget to click that like button. I know these videos are very useful. See you next time. Bye-bye.